Hello, everyone. I'm Bill Milligan, VP of Business Development for AventaCell Biomedical. Welcome to our global showcase, Scalable MSC Manufacturing in 3 bioreactor systems using HPL supplements. Our speaker today is Dr. Claudia Lobato da Silva, Assistant Professor, Department of Bioengineering, ISCT, University of Lisbon. Claudia's research in the Stem Cell Engineering Research Group of the Institute for Bioengineering and Biosciences at ISCT includes expansion of human stem cells, cell therapies with human adult stem cells, production of extracellular vesicles, and bioreactors. In these areas, Claudia is co-author of more than 80 scientific articles published in international peer-reviewed journals and 14 book chapters. Currently a member of the Pedagogical Society of ISCT, Claudia also serves as associate editor on the editorial board of BMC Biotechnology. And from 2015 to 2019, Claudia was VP of the Portuguese Society of Stem Cells and Cellular Therapies. Welcome, Claudia. Thank you for joining us today.
Thank you, Bill. Thank you for the kind introduction. It is my great pleasure to share with you some of the advances that we have been achieving at IBB-IST in Portugal, focusing on the scalable manufacturing of mesenchymal stromal cells. So as you know, mesenchymal stromal cells can be obtained from different tissue sources, namely from the bone marrow, which is the most well-characterized source of mesenchymal stromal cells. Although alternative adult sources exist, namely the adipose tissue as well as the synovial tissue, we are particularly interested in neonatal sources of mesenchymal stromal cells, namely the umbilical core matrix. In this table, you can see an overview of the typical mesenchymal stromal cell manufacturing platforms, such as the conventional planar multi-layered stack systems, where we can generate lots of cells in the range of 100 billion cells. These are a low-cost solution, although the main disadvantage is the fact that it's quite labor-intensive unless you couple some automation into the system. So alternative platforms are needed, namely bioreactors. Here you can see one option is the usage of perfusion bioreactors. For instance, holofibers. In these systems, you can generate 400 to 600 million mesenchymal stromal cells. In this system, the surface area is provided by the holofibers inside the bioreactor. And since you cannot monitor the cell counts directly, you should perform inline monitoring of the metabolites and key nutrients to evaluate cell growth. In terms of disadvantages, I should highlight that the scalability of these systems is still uncertain, and it's relatively high cost compared to other bioreactor systems. Another strategy is the usage of stirred suspension bioreactors combined with the microcarriers for immobilization of the cultured cells. So in this case, you can generate lots of cells also. But the thing is that this system is readily scalable to larger volumes. The main disadvantage of culture systems using bioreactors with microcarrier technology are in fact the technical challenges related with the processing of the beads, namely at the downstream. Upon the expansion of the cells, you have to make sure that you do not have any microcarriers or any particulates along with your cell product. So in this image, you can see an overview of some of the bioreactor geometries that have been used for stem cells in general, and in particular also for mesenchymal stromal cells. The mechanically agitated bioreactors, such as the stir tank, and also the wave bag bioreactors and orbital shakers. Also perfusion bioreactors that do not include mechanical agitation, such as the packed bed or the fluidized bed bioreactor, as well as the holofiber that we mentioned in the previous slide, and also the most conventional culture systems, which are planar technologies, namely the cell stacks. Here on top of the image, you see that depending on the bioreactor that you are using, you can cultivate the cells into different cell growth formats, namely in microcarriers and holofibers, and this will be the main focus of my presentation today. An alternative growth format could be to cultivate mesenchymal stromal cells as 3D aggregates. In this first case study that I want to share with you, we demonstrate the feasibility of using a human platelet lysate supplement for the isolation and scalable expansion of mesenchymal stromal cells from the umbilical cord tissue. So in this case, we were able to isolate effectively cells from explant umbilical cord cultures using these HPL supplements. And then upon initial consequent passaging, we generated 4 million mesenchymal stromal cells from the umbilical cord, and we inoculate these into a small spinner flask system with a working volume of 80 milliliters. We used plastic microcarriers to immobilize and to support the adhesion of mesenchymal stromal cells, and in this case, we use a solution of the same HPL supplement as an adhesive agent to promote the adhesion of the cells into the plastic microcarriers. Here you can see a successful growth curve for the umbilical core matrix cells grown on top of the plastic microcarriers in this system. The initial cell adhesion is not perfect, although we were under optimized conditions, we could attain more than 50% initial cell adhesion to the beads. And as soon as these cells attach to the beads, they can grow and attain exponential cell growth throughout culture. So overall, you can see here throughout time in culture, the gradual occupancy increasing throughout time, okay, with the cells on top of the plastic microcarriers. And at the end, after a short-term period of culture, 5 to 6 days, we attained a 13-fold increase of mesenchymal stromal cells from the umbilical core matrix. And we demonstrate that these cells maintain their identity, namely the immunophenotype assessed by flow cytometry, as well as their multilineage differentiation capacity. So having established this culture media strategy with a HPL supplementation, we decided to test a completely different bioreactor approach, in this case, holofiber bioreactor, where we do not need to use microcarriers. So this is the fully closed automated holofiber system called Quantum from Turumo. And this was done in collaboration with Professor Camila Switch from the University of São Paulo in Brazil. In this case, we used 30 million cells of the adipose tissue to inoculate the quantum system. We used the same basal media supplemented with the HPL, but this time we used a more advanced HPL supplement in such a way that is a fibrinogen depleted product. And when we compare our study with those reported in the literature using the same quantum system for mesenchymal stromal cells, namely the bone marrow, adipose tissue, and also periosteum tissue, we can see that our study was innovative in a way that replaced the usage of fetal bovine serum by a humanized culture supplement, HPL in this case, with a 5% supplementation. In the quantum bioreactor system, not all the cells attach to the fibers at the beginning, and according with the manufacturer information, roughly 70% of the cells successfully attach to the fibers, and this is the cell numbers that we have here indicated as the cells that were inoculated into the system. And you can see that upon a short culture duration of 5 days, our cell productivity, which is the number of cells generated per day, can surpass the performance of the other studies in the literature at that time. Throughout time in culture, we were able to follow the evolution and the concentrations of key nutrients and metabolites. In this case, lactate as a metabolite is a key concentration to follow, because we have to adjust the perfusion rate in the system. So overall, we can reach a clinically meaningful cell dose of 240 million cells after 5 days in culture. Importantly, upon enzymatic harvesting, at the end, we demonstrate that the cells maintain their identity attested by flow cytometry, as well as their multilineage differentiation capacity along 3 mesodermal lineages. Then, the next approach was to use the same strategy in what concerns the culture media to be used with the HPL supplement, the fibrinogen depleted supplement, but this time in a novel bioreactor configuration, which is the vertical wheel bioreactor. So in this case, we tested the usage of 2 different sources of mesenchymal stromal cells, both umbilical core matrix cells and also adipose tissue. We inoculated 5 million cells into a small vertical wheel bioreactor with a working volume of 100 milliliters, okay? And using exactly the same strategy, which was to use the solution of the platelet lysate itself also as adhesive agent to promote the adhesion of the cells onto the microcarriers. So here in these images, you can see successful growth curves for both umbilical core matrix cell at your left and also adipose tissue cells at your right, okay? We have validated these with 3 independent donors for each source. And here in these images, you can see once again the increasing gradual occupancy of the microcarriers in both umbilical core matrix cells throughout time in culture, as well as the adipose tissue. In umbilical core matrix cultures, the cell densities attained were the highest, okay, roughly 500 million cells per ml. While for the adipose tissue, they were a bit lower. Overall, in terms of fold expansion, we attained a 21-fold increase for the umbilical core matrix cultures, and also a 9-fold increase for the adipose tissue. Importantly, when we do a side-by-side comparison with conventional planar systems, we observe a reduction in the production cost when using the bioreactor. So overall, I hope I have demonstrated to you the successful scalable expansion of human mesenchymal stromal cells from different tissue sources in different bioreactor configurations, mechanical agitated with microcarriers, and also holofiber reactors using HPL supplements. We anticipate that safer HPL supplements that are pathogen reduced might be used without impacting the performance of the system. And we can optimize the culture parameters to have a more cost-effective mesenchymal stromal cell manufacturing. So to finalize my presentation, I would like to acknowledge all our team members, namely our director, Professor Joaquim Cabral, also our collaborators, namely Professor Camila Suiach from the University of São Paulo in Brazil, and also our collaborators from the companies involved in the study, and also acknowledge the funding. Thank you for your attention, and now it's your time, Bill.
Thank you, Claudia. Very interesting presentation and a lot of information in a short period of time, so thank you. I'm just trying to advance my slide. There we go. A little bit more information on the UltraGrow supplements that Claudia was referring to in her research. All of the UltraGrow brand products are manufactured from expired platelets sourced from AABB accredited and FDA registered US blood centers. And all products have full donor traceability. AventaCell supplies brand supplements, UltraGrow brand supplements globally. And by doing that, we've accumulated a reference library of applications for HPL and fibrinogen depleted HPL supplements across a range of cell types. All UltraGrow brand supplements are available both in research as well as in GMP grade, and the GMP grade with or without PRT treatment in 50, 100, and 500 ml SKUs. UltraGrow Pure and UltraGrow Advanced supplements have US FDA master files. Just advancing the slide again. If we look specifically at our new UltraGrow Pure gamma irradiated product, this is a GMP xeno-free product for use for clinical development and commercial production. This is an excellent choice for clinical HPL, or human platelet lysate. It's superior in replacing FBS or serum-free medium and producing high quality clinical grade or commercial cells. It is pathogen reduction treated with gamma radiation, and we show up to 5 log reductions across numerous viral families in our spike virus research validation studies. There's an FDA type 2 master file for this product, as well as a PMDA certificate for Japan, and it's compliant with the EU Pharmacopoeia 5.2.12.4 guidelines. It's a cost-effective option for higher yields and shorter doubling times. And to order samples or product of any of the UltraGrow brands, you can visit sales at atcbiomed.com. And with that, I'll thank Claudia again. I'll thank the audience. And for product fact sheets, posters, more information on UltraGrow supplements, as well as publications on the material that Claudia presented today, and regulatory references related to the master files in Japan, US, please visit our exhibit booth, which will be in the ISCT Paris 2020 virtual exhibit hall, and we'll be there for the duration of the meeting, as well as up until May of 2021. So anytime you need information on these products or information on Claudia's presentation on the HPL use in the bioreactors, please visit us. Thank you very much. Bye now.